Hello all, welcome to Narayana Group. I am going to discuss 18th morning shift physics paper. All these questions are memory based. There may be small change in original questions and these questions. Let us start the discussion. This is the first question. If a simple pendulum completes 200 oscillation in 100 seconds, least count of watch is 1 second, length of simple pendulum is 100 centimeter and its least count is 1 mm. Then find maximum possible percentage error in measuring acceleration due to gravity. We know that general expression for time period of simple pendulum is t equal to 2 pi into square root of L by G. Let us rewrite this expression in terms of G. So which will be G equal to 4 pi square into L by T square. Now let us find the percentage error in the calculation of G. So let us write this as delta G by G. We know that 4 pi square is a constant quantity, so there will be no error in that. It can be written as delta L by L delta L by L minus 2 times of delta T by T. As L and T are independent quantities, I can choose delta T as negative also. It may be plus or minus delta T. So it can be rewritten as delta L by L plus 2 times of delta T by T. Now let us substitute these values. Here it is given delta L as 1 mm. This is 1 millimeter by length of pendulum given as 100 centimeters plus 2 times of delta T is 1 second for 100 seconds. Error in the calculation of time period is 1 second for 100 seconds. Now delta G by G into 100 gives percentage error. This will be equal to 0.1 centimeter by 0.1 centimeter by 100 centimeter into 100 plus 2 times of 1 by 100 into 100. So it is clear 0.1 plus 2. So percentage error in the calculation of G is 2.1%. Let us go to the second question. It is given with option 3. The second question, a girl is looking at the distant rectangular window. She finds window to be blurred and non-uniformly curved. What eye defect she may have? Here it is given, she finds window to be blurred. First of all, she is observing blurred image for distant object means she is suffering from myopia. Basically, myopia means nearsightedness. She can view the objects which are up to certain distance. For example, this is some D. Some object is present at a distance D. If object is far away from D, she can't observe the image properly. It looks like blurred image. So she is having myopia, that is 1 point. Apart from this, it is given non-uniformly curved. This non-uniform curvature is because of sphericity of eye. That is called astigmatism. The defect of eye because of sphericity of. It is not a perfect lens as it is a sphere like this. Because of this defect, point object may not form point image. If it is no astigmatism, the image will be formed like this. If eye is having astigmatism, the image will be formed like this. So it is not a point image. So she is suffering from both myopia and astigmatism. So answer will be first option. Let us go to the third question. Here it is given simple electric circuit. In the circuit shown, evaluate potential difference across 10 ohm resistor in volts. So this is simple electric circuit given. First of all, let us try to find current in the circuit. Resultant current in the circuit can be written as I equal to 70 volts by effective resistance 10 plus. Here 50 and 20 are in parallel. That combination is in series with 10 ohm. So this can be written as 50 into 20 by 50 plus 20. This can be rewritten as 70 by 10 plus. This is 1000 by 70, or can be written as 100 by 7. Multiplying with 7 in the numerator and denominator, it will be 490 divided by 70 plus 100. This is equivalent to 490 by 170, or this is 49 by 17. This is current flowing through the circuit. Now the current flowing through 10 ohm resistor is same as that flowing through the battery. So potential difference across 10 ohm resistor will be 10 times of I. So this is 49 by 17 into 10. This is clearly 490 by 17. On simplification, it is 28.8 volts. So answer is 28.8 volts. Let us go to the fourth question. Here it is given, a satellite revolves in a circular orbit of radius r around Earth with time period t. Find its time period if it starts revolving in radius 9r. So it is simple Kepler's third law. T is time period when it is revolving in a circular orbit of radius r. And what is the time period when it is revolving in a circular orbit of radius 9r? Simply we know that according to Kepler's third law, t square proportional to r cube. This is law of orbits. Now let us rewrite this. T2 by T1 whole square can be written as R2 by R1 whole cube. So T2 by T1 can be written as R2 by R1 is 9R by R whole power 3 by 2. So this is 9 power 3 by 2. So it is clear. It can be written as 3 square power 3 by 2. So this is 3 cube. Simply it is 27. So new time period is 27 times of original time period. So option is given with the fourth one. Let us go to the fifth question. Here it is given, AC circuit diagram is shown. Find time taken to reach its current from IRMS to Imax. Actually here initial phase is not mentioned. Let us just take the ordinary function V equal to V naught sin omega t. He is asking time from current to change from IRMS to Imax. We know that it is purely resistive AC circuit. Current will be in phase with applied voltage. So current in the circuit can be written as I equal to I naught into sin omega t. Let T1 be the time at which current flowing through the circuit equal to RMS value. That can be written as, we know that RMS value of sinusoidal function is I naught by root 2. So I naught by root 2 equal to I naught times of sin of omega T1. Similarly, when maximum current is flowing through the circuit, that is nothing but I naught. This is I naught into sin of omega T2. From these two equations, it is clear omega T1 equal to pi by 4. Omega T1 is equal to phase of pi by 4. Similarly, omega T2 is equal to phase of pi by 2. Now, it is clear from this T1 equal to pi by 4 times of omega, T2 equal to pi by 2 times of omega. Difference of these two times to be calculated. T2 minus T1, it is clear, pi by 2 omega minus pi by 4 omega will be equal to pi by 4 omega. Now let us substitute the value of omega. It is given frequency of source is 50 hertz. So omega will be 2 pi times of frequency. So this is 100 pi hertz. So this is pi by 4 into 100 pi. Pi gets cancelled. This is 1 by 400. So it can be rewritten as 2.5 milliseconds. 2.5 into 10 power minus 3 seconds. It is given with third option. So it is correct. Let us go to the sixth question. Here it is given in LCR circuit L and C are constant and R is increased. Then he is asking about quality factor and bandwidth. First of all, let us write the general expression for quality factor. Quality factor in LCR series circuit can be written as Q equal to omega L by R, or it can also be written as omega by delta omega. So it is clear from this expression the bandwidth delta omega equal to R by L, and omega can be written as it is corresponding to resonance frequency. This can be written as one by square root of LC into L by R. Rewriting this, it will be square root of L by C into 1 by R. Here it is said that L and C are constants. If L and C are constant and R is increased, it is clear the quality factor will be reduced. Now let us check the options. Quality factor and resonance frequency both are unchanged. It is not correct. Quality factor is increased. It is not correct. Bandwidth is increased. It is clear from this expression delta omega equal to R by L. As R is increased, bandwidth increases as L is constant. So third option is correct. Let us go to the next question, seventh question. Here it is given in YDAC setup, distance between slits is 0.5 mm. Separation between slits plane and screen is 0.5 meter. Find distance between first maxima and third maxima if light used has wavelength 5890 angstroms. We know that separation between first and third maxima will be equal to 2 fringe widths. If I assume this is first maxima, this is third maxima, this separation equal to 2 times of fringe width beta. We know that general expression for fringe width beta as d by d into lambda. Capital D by small d into lambda. We know the notations of small d and capital D. Capital D is separation between slit plane and screen. This is given as 0.5 meters. And small d given is 0.5 mm. So this can be written as 5 into 10 power minus 4 meter in SI units. Wavelength given is 5890 angstroms. So this is 5890 into 10 power minus 10 meters. This can be simplified. This 5 and 5 is getting cancelled. So it is 5890 into 2 into 10 power minus 4 minus 6. It will be minus 7. Now this is 0, 18, 9, 11 into 10 power minus 7. So this can be, sorry, this will be 7. So it can be rearranged as 1178 into 10 power minus 6. It is given with first option, so it is correct. Let us go to the 8th question. Here it is given a closed current carrying loop is placed in uniform magnetic field, then in equilibrium shape of wire will be. Suppose let us assume that this is a closed current carrying wire carrying some current I. Initially it may not be circular in shape, just it is given it is closed. Let us assume that there exists a uniform magnetic field B in this region, assuming it is perpendicular to plane of loop. Then each and every element of loop experiences magnetic force according to Fleming's left hand rule. If central finger shows the direction of current, forefinger shows the direction of magnetic field, thumb represents the magnetic force. In accordance with this, magnetic field can be assumed to be outward, or let us reverse the direction of current here. Assuming current to be flowing like this. Now it experiences outward force in all directions. As it is experiencing outward force, just like force of surface tension, it acquires a circular shape like this. In equilibrium, it will be a circle with its plane perpendicular to magnetic field, but it is in the state of tension because of magnetic force. So the given options, it won't be straight line. Anyway, there will be a change. Circular and plane perpendicular to magnetic field will be the proper option among the 4 options. Let us go to the next question. The 9th question, it is given a muon particle having mass 207 times of mass of electron revolves around hydrogen nucleus. Find its ionization energy. Is saying that it is revolving around the nucleus. Suppose if you neglect the motion of nucleus, just like electron revolving in the hydrogen atom, he is asking about ionization energy. We know that the energy of electron in the nth orbit, while it is revolving in the circular orbit, will be proportional to mass of electron. So it can be written as some constant into mass of electron. Similarly, in the second case, it is proportional to mass of muon. Let it be En prime. If you neglect the motion of nucleus, this is the situation. Directly we can write En prime by En as mass of muon by mass of electron. This is equal to 207, it is given. In this way we are getting En prime equal to 207 times of ionization energy, 13.6 electron volts. In this way we get the third option. But if you consider motion of nucleus also, as it is having comparable mass of muon, mass of proton is just 1836 times of mass of electron. If I consider motion of proton also, then the situation will be like this. Initially En proportional to mass of electron. In the second case, En prime can be taken as proportional to mu, the reduced mass of muon and nucleus. So the reduced mass will be just like Mp into Me by Mp plus Me. This will be equal to 1836 times mass of electron into, this is muon actually, Mu. 207 divided by 1836 plus 207. If you substitute this expression, this will be En prime in this case will be mu by me times of En. Here we left with mass of electron. So it can be rearranged as 13.6 times of 1836 into 207 by 1836 plus 207. This particular value is not given in the options. So let us see, it may be third option or they may delete this question. Let us go to the 10th question. An object is moving with constant acceleration. Choose correct option. Here it is given position time graph, velocity time graph and acceleration time graph. It is mentioned that acceleration is constant. A is a constant quantity. If acceleration is constant, velocity can be written as simply A into T. Displacement as a function of time can be written as half A T square. So velocity time graph will be straight line with constant slope. It may have initial velocity, we don't know about that. Similarly, displacement time graph is parabola like this. So, and acceleration time graph is parallel to x-axis like this, as it is having constant acceleration. So all these three curves are properly given in fourth option. So the fourth option is the correct one. Let us go to the 11th question. A ring of mass m is rotating with constant angular velocity omega about axis of rotation, passing through center and perpendicular to plane of ring. Two particles each of mass m are placed gently diametrically at opposite position. Find new angular velocity. So initially the situation is like this. Ring is revolving with angular velocity omega. It is having mass m. Assume r is its radius. After two particles each of mass small m are placed gently diametrically at opposite positions. In the new situation, it is like this. Each particle of mass m are gently placed on the diametrically opposite points. Now let us assume omega prime is the new angular velocity of the system. The angular momentum of system is conserved here, as there is no external torque acting about axis of rotation, which is passing through center of mass and perpendicular to plane. Now initial angular momentum of system is simply mr square omega. In the second case, the angular momentum of system is omega prime into new moment of inertia. New moment of inertia is moment of inertia of ring plus two particles. Moment of inertia of ring is simply mr square, and that of two particles is 2 times of m into r square. So equating L1 and L2 and rewriting it for omega prime, it will be mr square omega divided by mr square plus 2 times of m into r square. After simplification, it will be m omega by capital M plus 2 times of small m. It is given with second option. Let us go to the 12th question. Electromagnetic wave is propagating in x direction. It is mentioned clearly. Magnetic field in space is given by B bar equal to 2 into 10 power minus 8 Tesla K cap. The direction of magnetic field is clearly mentioned along positive z direction. What will be the value and direction of electric field? We know that when an electromagnetic wave is propagating along x direction with velocity v, electric field will be in the y direction, magnetic field will be in the z direction, or we can write the expression for direction of magnetic field as direction of propagation cross direction of electric field. V cap cross E cap. Similarly, the direction of electric field can be written as B cap cross V cap, and the magnitude of electric field in terms of magnetic field is E equal to B into V. As it is given in free space, it will be B into C. So first of all, the magnitude of electric field is 2 into 10 power minus 8 times of C is 3 into 10 power 8. This is the velocity of light. It is 6 units. And the direction B cap cross V cap is K cap cross I cap. This is J cap. So it will be 6 times of J cap. This is the electric field. It is given with second option. Let us go to the 13th question. A machine starting from rest delivers constant power P, then distance traveled by it in time T is proportional to. It is said that power delivered by the machine is constant. We can write power equal to force into velocity. Force can be written as mass into acceleration. So it is mass into acceleration into velocity. Again, acceleration can be rewritten as dv by dt. So P by m into dt equal to v dv. Integrating on both the sides, integral of P by m dt equal to integral of v dv. Let us assume it is varying from 0 to v, it is assuming from 0 to t. So it will be P by m into t equal to v square by 2. Let it be equation 1. Similarly, the same expression can be written as P equal to m into v into a can be rewritten as v dv by ds. V dv by ds. Taking ds this side, again P by m into ds equal to v square dv. Integrating on both the sides, so it is P by m into integral of ds varying from 0 to s equal to integral of v square dv varying from 0 to v. So this is P by m into s. This will be v cube by 3. This is equation 2. Now from 1 and 2, we can eliminate v term. So here it is clear, s proportional to v cube, here v proportional to square root of t, s proportional to square root of t whole power 3. So it is proportional to t power 3 by 2. It is given with option 3. Let us go to the 14th question. An object is performing simple harmonic motion with time period 2 seconds. If time taken by it to move from mean position to half of amplitude is 1 by k seconds, then the value of k is. Already it is mentioned that time period of particle performing SHM is 2 seconds and is asking time taken to move from mean to half the amplitude. Assuming this is mean position, this is amplitude. So when a particle starts moving from mean position, the equation of motion of particle can be written as x equal to a sine omega t. When it is at mean position, we can assume t1 to be 0. So x equal to 0 at t1 equal to 0. Similarly, x equal to a by 2 at t equal to t2. A by 2 equal to a sine omega t2. From this it is clear omega t2 equal to pi by 6 because it is 30 degrees. Now the value of t2 equal to pi by 6 times of omega. Now time taken is difference between t2 and t1. This will be delta t equal to t2 minus t1. This is simply pi by 6 times of omega. Time period given is 2 seconds. The value of angular frequency omega will be 2 pi by t. This is equal to pi simply. So if I substitute the value of omega as pi, we left with 1 by 6 seconds as the time required. He is asking the value of 1 in 1 by k, he is asking the value of k. 1 by k is 1 by 6, so the value of k will be 6. So it is given with second option. Let us go to the 15th question. The given PV graph, process CA is adiabatic. It is mentioned C to A is adiabatic. Find work done in process CA if gas is diatomic. The value of gamma is mentioned. He is asking work done in the adiabatic process. The general expression for work done by the system or by the gas in adiabatic process is P1 V1 minus P2 V2 by gamma minus 1. Let us use that expression simply here. So work done in adiabatic process is P1 V1 minus P2 V2 by gamma minus 1. Here P1 means pressure corresponding to C. Similarly, V1 means volume corresponding to point C. Similarly, P2 V2 are corresponding to point A. Let us substitute these values. P1 V1 corresponding to C are 104. So this is 100 into 4 minus P2 V2 are 203. 200 into 3 divided by gamma given as 1.4 minus 1. So this is 400 minus 600. It will be minus 200 divided by 0.4, or it can be rewritten as minus 2000 by 4. This is equivalent to minus 500 joule. So it is given with second option. Let us go to the 16th question. Four identical solenoids are connected as shown in figure. If magnetic field in A is 3 Tesla, evaluate the magnetic field in C. If I is current flowing through A, due to symmetry, current flowing through B, C, D will be I by 3. So through C also it will be I by 3, through D also it will be I by 3. Suppose if magnetic field produced by current I in solenoid L is mu naught Ni, then magnetic field produced by I by 3 in C will be mu naught N into I by 3. It is mentioned that solenoids are identical. So number of turns per unit length are same. As current is becoming 1/3, this will be BA by 3. We can neglect the mutual inductance as it is mains level question and he did not mention anything about that. So directly it is 1/3 of magnetic field of B. So in B it is 3 Tesla, so it will be 1 Tesla in C. So answer will be 1. Let us go to the 17th question. In a wire, 5 volts of voltage is applied. Current flowing given is 2 amperes. Length of wire 10 centimeter and diameter 5 millimeter. He is asking to evaluate delta rho by rho into 100, means percentage error in the calculation of resistivity of the wire. We know that the general expression for resistance of wire of length L, cross section area A with resistivity rho as R equal to rho A by L. This is the rho L by A. This is rho L by A. It can be rewritten in terms of resistivity as rho equal to RA by L. A can be written as pi d square by 4. Diameter of wire is given, length of wire is also mentioned. Now let us write the expression for percentage error of this. First of all, rho equal to some constant into R into d square by L. Delta rho by rho can be written as delta R by R plus 2 times of delta d by d plus delta L by L. As all are independent quantities, error in delta L can be taken as a negative, then it will become positive quantity. Now again delta R by R. We know that R equal to V by I according to given information. So delta R by R can be written as delta V by V plus delta I by I. Here also V and I are measured independently. So delta R by R can be written as delta V by V plus delta I by I. So let us rearrange this expression. Delta R by R can be written as delta V by V plus delta I by I plus 2 times of delta D by D plus delta L by L. Here it is not mentioned separately the errors in the calculation of those quantities. In that case, we can take the last integral part. After decimal, it is having one significant digit. So, error in the calculation of V can be taken as delta V can be taken as 0.1 volt. Similarly, error in the calculation of current can be taken as delta I can be taken as 0.01 ampere. It is measured up to 2 decimal accuracy. Similarly, delta L can be taken as 0.1 centimeter. This is 0.01 ampere, 0.1 volt. Similarly, delta D can be taken as 0.01 millimeter. Now using those quantities, delta V by V can be written as 0.1 volt by 5 volts plus delta I by I 0.01 ampere by 2 amperes plus 2 times of delta D 0.01 millimeter by D given is 5 mm plus delta L 0.1 centimeter by length given is 10 centimeters. Multiplying the whole expression with 100, it is asked to find delta rho by rho into 100. So after multiplication with 100, we will get 0.1 into 20 plus 0.01 into 50 plus 2 times of 0.01 into 20 plus 0.1 into 10. So let us rewrite this. Here it is 0.1 into 20, this is 2 plus 0.01 into 50, this is 0.5 plus 2 into 20, 40 into 0.01, this will be 0.4 plus 0.1 into 10, this is 1. So finally this is equivalent to 3.9%. So it is given with first option. Let us go to the 18th question. A is forming B and B is independently. It is given A is forming B and C independently if A to B having half-life T half B and A to C having half-life T half C, then what will be overall half-life? It is given that A is producing B with half-life T half B. A is also producing C separately with half-life T half C. That is what given. He is asking effective half-life of A. Suppose if lambda 1 is disintegration constant for formation of A into B and lambda 2 is disintegration constant or probability of disintegration for conversion of A into C, then effective disintegration constant will be lambda 1 plus lambda 2. We know that lambda proportional to 1 by T half. So in that case 1 by T effective will be 1 by T1 plus 1 by T2, or T can be rewritten as T1 T2 by T1 plus T2. So means T AB into T AC by T AB plus T AC. It is given with first option. So let us go to the 19th question. Two wires A and B of same material having elongation 2 mm and 4 mm respectively on applying 2 Newton force on both. It is given A and B made up of same material, means both are having same Young's modulus. Young's modulus of A and Young's modulus of B are same. By application of same force of 2 Newton on both, elongation produced given is 2 mm and 4 mm. If radius of B is 4 times of radius of A, it is given radius of B is 4 times of radius of A, and ratio of length of A to B in the form of 1 by x. He is asking length of A, length of B ratio as 1 by x, and we need to calculate the value of x. Let us write the general expression for elongation. Delta L equal to FL by YA, or delta L by L is strain, that is stress by Young's modulus. Here it is given same material, so Y is common for both and applied force is also same, so F is also common for both. Then delta L is depending on length by cross section area, or rewriting it for L, L proportional to delta L into area. Now delta L of, he is asking L of A by L of B. L of A by L of B will be delta L of A by delta L of B into area of A by area of B. Area can be written as pi r square form. So it will be, first of all, delta LA by delta LB is 2 by 4 into RA by RB whole square. This is 1 by 2 into RA by RB is 1 by 4. So this is 1 by 4 whole square. Finally, this is 1 by 32. He is asking to compare this with 1 by x. So x value will be equal to 32. So answer should be 32. Let us go to the 20th question. A man is swimming in a river at an angle 120 degrees with river flow. Speed of man in still water is 10 meter per second. If he reaches the other bank exactly opposite to origin point, find speed of flow of river. He is saying that, assuming this is the direction of river flow, VR to be velocity of river. A is the starting point, B is the point which is exactly on the opposite bank, opposite to A. And his direction of swimming making 120 degrees with river flow, assuming river to be flowing along x direction. This is velocity of man with respect to river. In order to reach the point B directly opposite to the starting point A, the component of resultant velocity perpendicular to line AB should be 0. So let us resolve VMR into two components. This will be 30 degrees. So component of VMR in this direction will be VMR cos 30. In this direction it is VMR sin 30. VMR sin 30 should balance velocity of river. Then resultant will be along AB. So it is clear VMR sin 30 equal to velocity of river. VMR is velocity of man with respect to river. So that is given 10 meter per second. So 10 into sin 30 is 1 by 2. This is velocity of river. It is 5 meter per second. So answer should be 5. Let us go to the 21st question. If ratio of de Broglie wavelength of particle and electron is 2:1 and ratio of their velocity is 4:1, then mass of particle is 8 times that of electron, mass of particle is 8 times that of particle, mass of electron is 16 times that of particle, mass of particle is 16. Just he is asking ratio of mass of particle to mass of electron in this case. He said that ratio of de Broglie wavelength of particle and electron. Let us write the general expression for de Broglie wavelength, lambda equal to h by p, where p is momentum of particle, p can be written as mass into velocity. So he is asking mass ratio. So general expression for mass can be written as h by lambda into V. As h is Planck's constant, it is common for both. So mass is inversely proportional to lambda and V in the given situation. So let us write the ratio of mass of particle by mass of electron. It will be 1 by lambda particle into velocity of particle by 1 by lambda electron into velocity of electron. Let us rewrite these values. It is given wavelength of particle and electron is 2:1. So lambda particle by lambda electron is 2:1. So it will be 1 by 2. Similarly, velocity of particle by velocity of electron 4:1. So this will be 1 by 4. So it is clear this is 1 by 8. So mass of electron is 8 times of mass of particle. From this we are getting like this. So it is given with second option. Mass of electron is 8 times that of particle. Let us go to the next question. In the Millikan's oil drop experiment, radius of drop given is 2 millimeter and density 3 gram per centimeter cube. If applied electric field is 3.55 into 10 power 5 Newton per Coulomb, find excess electrons. Means we need to calculate number of electrons present in the oil drop. So electric force acting on the oil drop is keeping it in equilibrium with gravitational force. In equilibrium, mg of oil drop is balanced by electrostatic force Q into E. Let us equate this. First of all, let us calculate the value of mg. This is 4/3 pi r cube into density of drop into G. 4 by 3 times of pi into r cube is 2 mm cube. This is 8 into 10 power minus 6 into density 3 gram per centimeter cube means 3 into 10 power 3 in SI units into the acceleration due to gravity. Let us assume it to be 10. Electric field strength given is 3.5 into 10 power 5. So in equilibrium, Q can be written as mg by E. This is equal to 8 pi can be taken as 25. So this is 4 by 3 times of 25 into 3 into 10 power. This is 10 power 4 and minus 6. It will be 10 power minus 2 divided by electric field strength given is 3.55 into 10 power 5 Newton per Coulomb. Actually, we need to calculate number of electrons present. So total charge Q can be rewritten as number of electrons present into charge of electron 1.6 into 10 power minus 19 coulombs. From this expression, the value of N, first of all, this 3 and this 3 gets cancelled. 4 into 25 gives 100. 100 and 10 power minus 2 will be 1. So this is 1 divided by 3.55 into 10 power 5. And taking this term this side, it will be 1.6 into 10 power 19. Calculation of this gives 1.769 into 10 power 10. This much number of electrons are present in the oil drop. Let us go to the next question. A partially filled capacitor has half of its space filled with dielectric of relative permittivity 10. Equivalent capacitance if area of plates is 100 meters square and distance between plates is 10 meters is given as some constant x, picofarad. Find the value of x. Given that epsilon naught value as 8.85 into 10 power minus 12. So it can be considered as combination of two capacitors connected in series like this. One is corresponding to dielectric capacitor, other is air capacitor. Only the difference is separation to be taken as d by 2 because it is mentioned one is half of the space is filled with dielectric constant. So capacitance of dielectric capacitor can be written as C1 equal to K times of epsilon naught A by D by 2, where D is separation between the plates, K given as 10. Similarly, C2 can be written as epsilon naught A by D by 2. Let us assume epsilon naught A into D by 2 as a constant, that is 2 times of epsilon naught A by D. Let us assume this as some C naught. Then C1 will be equal to K times of C naught. Now series combination of C1 and C2, directly I can write C effective equal to C1 C2 by C1 plus C2. This is K times of C naught into C naught by KC naught plus C naught. This is K by K plus 1 times of C naught. Let us substitute the values. First of all, let us find the value of C naught. C naught equal to 2 times of epsilon naught A by D. 2 by D given as 10, area given as 100 meter square, and epsilon naught value 8.85 into 10 power minus 12. Substituting this value in this expression gives nearly 160.9 picofarads. So it can be round off to 161 nearly. Let us go to the next question. A ball is released from point A, evaluate its velocity in meter per second when it reaches to point B. Assume that frictionless surface. As it falls from A to B, vertical height descended by the ball will be 10 minus 5 meters. So directly we can write the expression as V square equal to 2G H. H is effective height descended by the ball in gravitational field. So this is 2 into G as 10, H as 5. So speed acquired by the ball will be 10 meter per second. So it is given as 10. Let us go to the next question. Here it is given initially a body of mass 10 kg moving along x-axis with velocity 10 root 3 meter per second. So 10 kg mass moving with velocity 10 root 3 meter per second collides with another body of mass 20 kg and comes to rest. So it is colliding with 20 kg block. This is the situation before collision. After collision, he said that 10 kg block is coming to rest. This is 10 kg block and 20 kg block. About 20 kg it is given. 20 kg mass object disintegrates in two parts, each of mass 10 kg. So it is splitting into two 10 kg blocks. One part moves along y-axis with velocity 10 meter per second, assuming this is part A, this is part B. Another at 30 degrees with x-axis. Part B is moving in this direction, which is making 30 degrees with x-axis. If V is velocity of part B, we need to calculate velocity of that. It is clear from the given situation, there is no y component of momentum initially. Even after collision also, there should be no y component of momentum. From the conservation of linear momentum, as there are no external forces acting on the system, we can conserve y component of momentum, initial and final. Initial y component of momentum 0, finally also it should be 0. So final y component of momentum of system is 10 into 10 j cap minus 10v sin 30 j cap. 10v sin 30 j cap. It should be equal to 0. So it is clear from this 10v sin 30 equal to 100. So V equal to 20 meter per second. So answer should be 20. Let us go to the next question, 26th one. A bullet of mass 0.1 kg initially moving with velocity 10 meter per second and then passes through wooden block and comes to rest with uniform deceleration by traveling 50 centimeter. If the force exerted by wooden block on bullet is x Newton, then find the value of x. So simple kinematic equations we can use. Here it is mentioned that deceleration is uniform. Let us use the equation v square minus u square equal to 2as. Final velocity is 0, initial velocity is 10 meter per second, 2 into retardation A, displacement is 50 centimeter or it is 0.5 meters. So the retardation A equal to minus of 100 by 1. So this is minus 100 meter per second square. Now force exerted by wooden block on the bullet. Force exerted equal to mass into retardation. It will be mass is 0.1 into magnitude of retardation is 100. So it will be 10 newtons. So answer should be 10. Let us go to the 27th question. A capacitor of capacitance 3 microfarad has charge 30 nanocoulomb is connected to a resistance of 5 ohm. If current in the circuit just after closing the switch is x milliampere, then x is, it is just a discharging RC circuit. Simply just after connections are made, this is capacitance C, resistance R having initial charge Q naught. The general expression for current in the circuit can be written as I equal to I naught into e power minus t by tau, where I naught is Q naught by tau or it is Q naught by RC. Just after switch is closed means this will be equal to I naught at t equal to 0. So the value of Q naught by RC should be calculated. Q naught mentioned is 30 nanocoulomb. So this is 30 into 10 power minus 9 divided by the value of resistance mentioned is 5 ohm and capacitance given is 3 microfarad. So this is 3 into 10 power minus 6. So simply it is 2 into 10 power minus 3 ampere. In milliamperes it will be 2 milliamperes simply. Let us go to the next question. Thank you.